Good afternoon together. My name is Olena Skrynnyk. In this workshop, I would like to present the results of the work of myself and Professor Tetyana Vasilyeva on management of organizational development measures. The presentation consists of three parts, in which I will define the problem, describe the particularities and the cause of the investigation, and derive a conclusion and outlook. So, we start with the problem formulation. Current management of organizational development measures is generally company-specific and contextual. Basically, the diagnostics, planning, implementation, regulation and control of such measures is conventional and involves several responsible persons. Within this complex process, there may be certain residual risks which may cause recurrence of the development. Companies would benefit greatly from using the potential of modern technology at every stage of organizational development. So you can see it for diagnostics, planning, implementation, and regulation and control. Considering the main objectives and fields of activity of organizational development, we can see that traditional measures require intensive planning, are performed over a long period of time, and the results are measurable only after a relatively period of time. In our research, we have found that covering these points will make organizational development much more effective. We have attempted to develop a solution to support the effectiveness of traditional measures by tracking the state of the organization through immediate measures. So, the main aim of our investigation is to achieve continuous improvement. To achieve this goal, we have designed a neurogenetic hybrid system that learns from its own experience to select the most appropriate measures to achieve organizational development goals and therefore to further improve itself and the organization. The system is designed for three organizational levels. The measurable performance and/or behavior serve as input. These are analyzed in further steps, and if they deviate from the desired state, one or a series of measures will be applied. In this workshop, we present only subsystem, which is applied to the individual level. The state on this level is measurable by behavior and/or performance. Some words about genetic algorithm. First, a new population of individuals is formed randomly, which means that every single gene, the set of parameters of every individual, is determined randomly. Second, with an evaluation of the individuals, each individual with the fitness function is assigned its fitness. In the third step, the selection is done, the best or fittest individuals survive, and all others are stored out. In the fourth steps, the individuals reproduce to get back to the basic population by simply copying or by combining. In the fifth and last step, some genomes are noted. This means that from some individuals, for example 10 or 5% of the total population, single gens are taken and changed or reversed. This leads to much more flexibility in the whole population and helps it, for example, local optima in the whole solution space. The result is a new generation, and now the whole game starts all over again and is evaluated again. Applying to our system, we have following architecture. The kinetic algorithm consists of three phases: initialization, selection, and mutation. The initialization of the initial population of solutions or measures is generally done by chance. Selection of best solution measure based on the corresponding of the behavior after applying of the measure with desired behavior. After the ensuring that the measure is successful, it will be selected as the first generation of parents. In mutation phase, the change of characteristics in the direction of improvement of the whole individuum, object, and so on happens. In our genetic system, the individual is a measure. The variables that characterize and systemize measure are the depth of influence, channel of mediation, and duration of implementation. These are included in the fitness function and determine the fitness, the effectiveness of the measure. As you can see, the general structure of the architecture consists of main following steps: implementation of measures to achieve the desired behavior, collection and recognition of input variables per face, voice, or text recognition and performance measurement system, analysis of behavioral components, comparison of emotions and act variables with target actions, analysis of motivation and needs in neural network, and repeat the steps 0 till 3. So we start with the first part of our subsystem. Uh, the, Now I would like to concentrate our attention on the neural fuzzy network and show how the behavior analysis can be implemented in the system of management of organizational measurements. The dependency chain behavior need is very important. If we look at this chain, we see that behavior is addicted to act and emotion, motivation, and need. And now we want to analyze which parameter made the input of our system. So we start with the input. Behavioral components, actions, are evaluated by analysis of act variables and emotions. Emotions are a subjective experience of need and satisfaction of this need, a way of determining needs and activating motivation behavior. Emotion recognition we based on facial expression, voice tone, speech context, context from text, words, sentences, expressions, and so on. So far, we have concentrated on 8 main emotions. These are fear, anger, sadness, joy, disgust, surprise, trust, and anticipation. The emotions can be strong, medium, and light, which is a challenge for the future of our system, as the total number of emotions and feelings exceeds 400. Example of emotion recognition is, for example, a dialogue between two employees. One of them shows trust, nod, and say, for example, yes, we are together, we understand this thing, we do it together. What we see yes, we see we see trust and nod. The important variables in capturing emotions are type, quality, duration, and intensity. Of course, there are some hurdles in the recognitions of emotions. I made a few examples. Act is defined by the same variables as emotion. Quality, duration, and intensity have different values. Different activity types can be assigned to groups or employee level. The type of activity defines the required software that can additionally check other act variables. Conversation and coordinating activity can be managed using speech recognition mechanism. Writing activity is analyzed through text recognition or a neural network. For manual activities are used, for example, MES or ERP systems. Then monitoring activity of specific activities requires task-related software. Other act variables are stored in the respective software. We investigated in employee evaluation portal Kanunu after most frequently occurring negative employee and applicant comments in view of organization climate and the soft factor in the enterprise. In addition to such focal points as weak leadership, poor further trading opportunities, and a lack of work-life balance, a lack of respect and acceptance for diversity. So we take an example of usage of forbidden words as non-conformity with compliance with higher ethical standards. Applying in behavioral context, as an act, it can be seen as conversation with unsatisfying quality, medium duration, and multiple iterations. In case of emotion, it would be anger with unsatisfying quality, medium duration, and a few iterations. Each combination of emotion and act corresponds to a set of motivational components. Each motivational component is related to specific needs. So you can see the relations between them in this matrix and also the rules that we made to realize how specific they can be. Even if you see all the 11 needs, not each of them is in motivational component. How does the described information flow into our system? The first measure from the pool of measures is selected. This is, for example, information about the values and ethical behavior in the company. Next comes the unwanted behavior of employees. This is detected by the system part of the emotion and act recognition. The behavior doesn't correspond to the desired or learned organizational goal. This means that the first measure was not effective. Neuro fuzzy system shown on the next slide analyzes the behavior motivation need chain and determines which main need is unsatisfied. The next measure selected from the pool would have as their goal to satisfy the main need and to effectively achieve the organizational development goal. In general, individual layers of neurofuzzy network can be described as follows. The first, the initial layer, is the layer where the outputs of the nodes are degrees in which the given input satisfies the functions associated with these nodes. The second is the rule layer. Each node calculates the intensity of the rule. All nodes can be selected to simulate logical end. The third level is normalization layer. Each node normalizes the intensity of the rule. The fourth layer is neuron output layer. Neuron output is the product of normalized rule intensity and individual rule output. The fifth layer is total output layer. Single output neuron calculates the network output. The neural network consists of such elements where the output of the level corresponds to the input of the other level. In case one of the variables does not occur, it is still recorded with minimum value. Our neurogenetic hybrid system works with a series of data that have fuzzy character. Therefore, the part of behavioral analysis and the part of motivation analysis were implemented as ANFIS. So, I want to show you how our neurofuzzy network looks like. At first, you see act and emotion with the components, and of course with the values of these variables. Then you see the rule layer, normalization layer, and neuron output layer. And of course, the fifth total output layer, where we see the motivation. From the other side, we see that our motivation consists of several needs. These needs are, we can say, combined, or they are in relation, which are described in the rule. So, our neurofuzzy network gives us the output as motivation. After that, from this motivation, the unsatisfied need is derived. The already described path can be displayed as such a chain. Finally, it can be said that the described subsystem has some advantages and limitations. As advantages, we can say management of special complex problems, learning from own experience, connection to ERP system conceivable, reduction of control and monitoring steps, timely provision of organizational development measures. There are also some limitations like higher training and learning effort, very long processing time, complexity, higher data volume, and preparation effort on the organizational side. In any case, our further steps are analysis of learnable personality orientations, for example, attention or will processes, then expansion to recognition of further emotions, expansion of recognition of further motivational components, and extension to further functions. Now I want to thank you for your kind attention and ask you if you have any questions.